because it's either there are freezing areas or the water is of very poor quality and very corrosive, and often lots of calcium, so therefore the flat plate collector can be completely clogged with too much calcium. So it must be remembered, it's best to say that throughout South Africa one should use an indirect system. Although it's 85%, play safe and do it throughout the country, use an indirect system. The guys are now connecting in the pressure temperature relief valves, tidying up behind there. Pipes at the back of the tank. This is a condition of the PIRB or IOPSA in that there must be 2 vacuum breakers on every system, and that's the process they're going through at the moment. Here they're drilling a hole through the roof to take the plumbing pipes through from the solar hot storage tank to the original plumbing, which was integrated with the conventional geysers. They're now installing the pressure temperature relief valve. There he is tightening up all the pipes. It's very essential, of course, that everything is absolutely tight and tested. This is the electrical installation, whereby there must be an electrical plug close enough to the tank so that should somebody, one of our service teams, come along to service the system, they must be able to switch the system off. The electrical section of the system, the 3 kilowatt element, they must have the ability to switch that off so that they're not in danger of being electrocuted. Here, the 5 litres of heat exchange fluid has been poured into this 20-litre container, and then they fill the 20-litre container with 15 litres of water, so you have 20 litres of mixed fluid. They're now making their connection, the electrical connection, and again that electrical connection was originally into one of the conventional geysers, and now it's been extended up through the roof and into this control box, which, as I said earlier, is positioned at the back of the storage tank to enable the serviceman to have access to control of the electrical supply to the system. This is where the pipes have gone through the roof, and this is the plumbing pipes, and now they seal it with black silicon, and that black silicon lasts for decades. It really is a very, very efficient way of sealing plumbing piping on a roof tile. Here they're doing the earthing, which is an essential and required compulsory activity on any electrical installation. Now they've just tested the water pressure. Now they are transferring the heat exchange fluid into the collector panels. And it's just a very simple process of connecting the pipe to the fill plug at the bottom of the collector panels, and the fluid sits in a 20-litre drum on top of the tank and passes through into the collectors. Now the guys have finished the installation and they're going around and they're removing here he's just cutting the pipes to continue connecting through into the roof, to the original plumbing piping. Frankly, has been completed. They do a pressure test with a pressure test kit to ensure that the fluid is operating and there is no leaks. They use a simple pump and they are pumping the pressure test kit up to 100 kPa, and that pressure test kit will ensure, while they're clearing up the roof, they keep checking that that has not dropped, and if that hasn't dropped, they can be sure that that pressure will stay for the next 3 decades. It will not, once it's sealed, it will not break down. Now we're sticking the barcodes onto the collector panels and onto the tank. This is a prerequisite by ESCOM, that each system has barcodes on it, and that's how the customer is entitled to a ESCOM rebate. You'll see the 20-litre drum sitting up on top of the tank. The fluid is passing naturally through into the collector panels. At this stage, they're sealing off the closed circuit. The tank, when it was installed on the roof at the beginning of the installation, was completely filled with 300 litres of water. And that's essential before we actually do the filling of the heat exchange fluid. You can see the roof naturally has to be a northerly facing roof. It doesn't have to be direct north. 45 degrees east to west of north, there's a minimum loss of efficiency. So anywhere within direct north to 45 degrees either side is quite adequate. Here, the occupant of the home who's bought the Solar Heart is in the process of completing the owner's manual, where she signs to establish she's happy with the installation, and at the same time she's given her ESCOM rebate form, again with the barcode on the form to ensure that it all complies with the system that's on the roof.
This structure is a replica of a typical domestic roof structure. A geyser tray is to be fitted and gets placed over bearers. The bearers must correspond with the geyser's feet. A drain pipe will be fitted to the geyser tray and will terminate outside of the building. The geyser is positioned on the geyser tray with the feet corresponding with the bearers. The geyser must be in a position for ease of access for maintenance or replacements. All fittings connected to the geyser should be of a union type for ease of maintenance and replacement. The pump must be installed with a non-return valve, and they must be installed in the same direction. They must also be fitted with union type fittings for ease of maintenance. We start with a cold water supply. Then we connect the hot water outlet to the house. Remember to take the pipe 200 mm away from the outlet before fitting the T for the 300 mm riser and vacuum breaker. Install the safety valve with a metallic pipe slipping away from the geyser, terminating over a safe area outside the building where the blow-off will not create a nuisance, a hazard or damage to property. Now we start with the cold water side of the collector loop. Fitting the pump in the direction from the tank to the collector.